to a course on calculus. We are talking about the concept of differentiation. In this lecture, we are going to do some problems on checking the derivative of a function, right? So the first function that we are going to consider is f of x is defined to be x sine 1 upon x when x is not 0 and 0 when x is 0, right? So here the function changes its behavior only when x is 0, and while checking the continuity we found that this function is continuous at 0. Okay, so if a function fails to be continuous at a particular point, then without even checking for the definition of differentiability, we can come to a conclusion that it is not differentiable at that point. The point that I'm trying to say is, if a function is not continuous at a particular point, the function cannot be differentiable at that point, right? So let us do the case when x is 0. So when x is 0, what we have to do? We have to do as limit x approaches x, f of t minus f of x upon t minus x. This is what we need to find. Here x is what? 0. Therefore, limit t approaches 0, f of t minus f of x upon, f of 0 upon t minus 0 is going to be t time, okay, limit t approaches 0, t times of sine 1 upon t minus 0 upon t minus 0. So this happens to be limit t approaches 0, sine 1 upon t. Since this t and t gets cancelled, this limit does not exist. Therefore, our f of x is not differentiable at x equals 0. Okay, next let us do the case when x not equals 0. When x not equals 0, the oscillation is not going to take place that anonymously. Hence we may do the calculation using a product rule, usual product rule that we have seen, that is f prime of x when x not equal to 0 is going to be having this sine 1 upon x as it is, and the derivative of x is going to be 1, plus having x as it is and the derivative of sine 1 upon x, which will be cos 1 upon x, and then here we will have to make use of chain rule as well. So this is going to be minus 1 upon x squared. Therefore this would be a sine 1 upon x minus 1 upon x times of cos 1 upon x. So this is the derivative that we get, and this is true when x is not equal to 0, right? So I think I don't need to spend much time on finding this kind of derivatives, that when x is not equal to 0, this kind of derivatives that we know, because people have studied these formulas and the ideologies to find the derivative in schooling itself, but not differentiability. Suppose we are given the function f of x is x sine 1 upon x, we simply find the derivative through this way, but this is possible only when x is not 0. This is something that we must have learned already, but let us learn now. Okay, let us go to the next problem. So that problem tells you that is your f of x is x square times of sine 1 upon x when x is not 0, 0 when x is 0. Here also I am leaving it as an exercise to find f prime of x when x is non-zero. Let me do only when x is 0, right? Okay, when x is 0, limit t approaches 0, f of t minus f of 0 upon t minus 0 is going to be limit t approaches 0, t square sine 1 upon t minus 0 upon t minus 0. So this happens to be limit t approaches 0, t square sine 1 upon t. So tt gets cancelled and we are left with limit t approaches 0, t times of sine 1 upon t, and this is 0. Hence f prime of x at x is 0 is 0. This function is differentiable everywhere. But if you go to find the derivative of its derivative, that is not going to be differentiable, right? So let us see another problem, that is the third one, right? So f of x is defined to be x for this case and 1 for this case. Okay, here also I am not going to check the continuity of the function when x is bigger than 1 or between 0 and 1. Let me check the let me check the differentiability when x is 1. Okay, so we are going to find out f prime of 1. So that is limit t approaches 1 f of t minus f of 1 upon t minus 1. So here I'll have to check left and right. So right derivative, that is limit t approaches 1 plus f of t minus f of 1 upon t minus 1. So 1 plus in the sense 1 plus, so this lands here, so it's going to be 1, and f of 1 is also 1 upon t minus 1, so this leads to 0. Okay, actually we have limit, right? So limit t approaches 1 plus this. Okay, let me give you the idea that we have seen in the limits itself. This shall be made to limit h approaches 0 f of 1 plus h minus f of 1. In the denominator also we will have 1 plus h minus 1. So it's going to be limit h approaches 0. 1 plus h means it's going to be 1 minus 1 upon h, which is 0, right? And the left derivative is going to be limit t approaches 1 minus. So it gets changed, right? F of t minus f of 1 minus f of 1 minus h upon it's going to be what? Simply h. Okay, 1 minus, it's going to be 1 minus 1 minus h. So it is limit h approaches 0. Okay, so here itself let us write it directly. Limit h approaches 0. So f of 1 is 1, 1 minus h. So it is going to be simply 1 minus h upon 1 minus of 1 minus h. This is what? This is 1. RD is not same as that of LD. Hence f of x is not differentiable at x is 1. If you find the derivative of the function at other points, you would get your f of x to be 1 when your x lie between this interval, and a 0 when your x is positive. Only at x is 1 the function is not differentiable, right? Thank you.